Welcome to clickmyproject.com. Let me discuss about the project Classification of Arrhythmic ECG data using machine learning techniques. Let me discuss about the abstract of the project. Detection of ventricular fibrillation and rapid ventricular tachycardia is crucial for the success of defibrillation therapy. A novel detection algorithm that combines ECG parameters with FNN to identify shockable arrhythmias has been presented. FNN learning algorithms can improve the efficiency for the detection of life-threatening arrhythmias. FS techniques might help to provide valuable insights to build highly accurate detection algorithms. Prompt detection of VT and VF episodes is crucial to deliver an electric shock therapy, and in this way increase the probability of survival from a SCA incident. The development of automated external defibrillators that analyze the surface electrocardiogram signal if either rapid VT or VF is detected. Ventricular fibrillation versus ventricular tachycardia, making it difficult to assess the real performance. In this previous method have used genetic algorithms or discriminant analysis. The performance of the proposed FNN detection used combine three different FS filter type techniques into a single ranking score, allowing us to determine the relevance of ECG parameter using the score in the FNN classifier to yield a robust result. In this approach, Hurst index and the PSR parameter was calculated. Case of FNN classifier using unbalanced dataset which provide arrhythmia detection problems. Temporal parameters, spectral parameters, and complexity parameters have been measured with the help of QRS complex detection. The B or metric is an interesting magnitude to set the free parameters of the algorithm. Detection performance of the analyzed parameter. This process is an interesting method for evaluating the discrimination ability of a set of ECG parameters performed well. This FNN algorithms combining ECG features significantly improves the efficiency for the detection of life-threatening arrhythmias. FS method has been combined to the FNN algorithm to provide a robust classifier using a reduced set of ECG parameters. In future, we implement multicast FNN classifiers. Let me discuss about the flow diagram for our process. In the input signal generation, here we use the ECG signal as an input signal. ECG signal need to be generated for processing and analyzing. Read input signal with the represented format. It showed as ECG waveform, mean subtraction, 5-order moving average filtering, high pass filtering, and low pass Butterworth filtering. A typical ECG signal depicts the series of waveform which occur in a repetitive order. In the signal preprocessing, a fast Fourier transform is an algorithm to compute the discrete Fourier transform, and its inverse Fourier analysis converts time to frequency and vice versa. An FFT rapidly computes such transformation by factorizing the DFT matrix into a product of sparse factors. There are many different FFT algorithms involving a wide range of mathematics, from simple complex number arithmetic to group theory and number theory. This article gives an overview of the available techniques and some of their general properties, while the specific algorithms are described in subsidiary articles linked below. The DFT is obtained by decomposing a sequence of values into components of different frequencies. This operations is useful in many fields, but computing it directly from the definition is often too slow to be practical. And in the feature extraction phase, we detect the QRS detection. QRS complex is a name for the combination of three of the graphical deflections seen on a typical electrocardiogram. It is usually the central and most visually obvious part of the tracing. It corresponds to the depolarization of the right and left ventricles of a human heart. In adults, it normally lasts 0.06 to 0.1 seconds. In children and during physical activity, it may be shorter. Next, finally, the feature values are classified with the FNN classifier, where the entire database signal features are also passed to the classifier. In the Here in the feed-forward neural network is an artificial neural network where connections between the units do not form a directed cycle. This is different from recurrent neural networks. The neural network for handwriting recognition is defined by a set of input neurons which may be activated by the pixels of an input image. A feed-forward neural network was the first and arguably most simple type of artificial neural network devised. In this network, the information moves in only one direction forwards. From the input nodes, data goes through the hidden nodes and to the output nodes. The simplest kind of neural network is a single layer perception network, which consists of a single layer of output nodes. The inputs are fed directly to the outputs via a series of weights. Finally, we analyze the result whether the signal is arrhythmia or shockable arrhythmia or non-shockable arrhythmia. We discuss about the running procedure for our process. Select the main.m file in the current folder, right-click that file and run for executing this process. This is the main window of the classification of arrhythmia ECG data using machine learning techniques. By pressing the input signal button, we can browse the input signal from the dataset folder. Select any one input signal from the dataset folder. Here I display the input signal in Axis 1 plot. By pressing the pre-processing button, we can remove the noise from the input signal by using the FFT transformation. By pressing the segmentation, we detect the QRS complex based on the input signal, where the QRS complex is detected. This is the heart rate is our input signal, that is 42, and this is the filtered smooth preprocessed signals, and this is the raw ECG signal. Here T wave, S wave and R wave are represented, and here the segmentation signal or that is sampled signal are plotted in Axis 2 plot. Here P wave, R wave, Q wave, S wave and T wave amplitudes are displayed in millivolt, and also the PR interval, QT interval, ST interval, P wave interval, QRS interval and RR interval are calculated and displayed in the edited box. Finally, we calculated the feature extraction values based on the statistical features. Here the feature extraction value will be displayed in a table format. After that, we analyze the result with the help of classification. Here we use the NNN classifier, that is feed forward neural network classifier. By pressing the classification button, we can analyze the signal. This is the performance of the neural network, and we got the result as ECG signal is arrhythmia. Thus, comparative analysis between the arrhythmia and non-arrhythmia have been detected from high variance, thus indicating there is an improved performance. Thank you.